And now, Odile, the floor is yours.
Thank you very much, Helmut, for introducing us together. So nice. My name is Odile Mekel. I work at the Subnational Institute for Public Health. It's called the Northern Westphalia Center for Health. My institute is located in Northern Westphalia. It's an area in Germany with a population of almost 80 million people, and Northern Westphalia has its own government. Germany national government, but also the Bundesländer, so North Rhine-Westphalia has its own government with the Ministry of Health, and we give advice to the Ministry of Health in all questions of health, but also we give advice to our local public health authorities. That we have 43 in total, and the range is between 110,000 inhabitants in this district, so one public health authority for 110,000 till also we have a large city, Cologne is also located in North Rhine-Westphalia with approximately 1 million inhabitants. So we give advice to the ministry, but also to the local health authorities. Today, my talk is about health impact assessment, and health impact assessment is definition you see over here. So it is a prospective thing. So we look at policy programs or projects, and we use a combination of procedures and methods and tools to judge the potential effects on health of the population, but also not only for the whole population, but also the distribution of these effects within the population. And for you to understand, so health impact assessment uses, there are specific steps or phases in health impact assessment. So in the beginning, you screen if a policy project or plan is having health impacts involved. If this is the case, then you go in the next phase, scoping phase, where you decide how far, how deep you dive into this in this exercise, and then in the appraisal phase, you assess the health impact assessment, which will lead to recommendations in a report, and in the end you will have some monitoring and evaluation parts. Where does quantitative modeling sit in this health impact assessment? It sits in the appraisal phase. So in the appraisal phase, we collect all the evidence and knowledge we have to judge this future plan, project, or program. And we have different methods, qualitative and quantitative methods. And my talk will concentrate on the quantitative methodology. Liz Green will do the qualitative parts. And as Helmut already said, in the beginning I will get a bit into the general aspects of doing health quantitative modeling, and then I will show you different approaches, and I will give you in the second part an example of modeling. How does it look like? And in the end, I give you some models that you could use to assess the health impact assessment of climate change programs, policies, and projects. So, quantitative approaches in health impact assessment, pros and cons. First, the disadvantages. And if you start to think about quantitative modeling, it could be not always the case that you can do it because the data is not there for effect estimates and also for baseline characteristics of the population. You need to consider that it is time consuming, and therefore also it takes time and therefore also costs. And one thing is that in modeling, you need to decide on what kind of parameter you put in, what kind of model you do, and you make you need to make assumptions. And for all, my recommendation, working already several years in this area, be explicit in what you are doing. But not all my colleagues are doing this. So this is sometimes critical, and therefore others call it voodoo. It's not voodoo, but it is a transparent approach. Also, people say, if you have a number 3 in 1,000 cases, it could be give an unwarranted patina of robust science, and it may omit or de-emphasize stakeholder engagement. But there are also a lot of advantages. It is a transparent approach. It gives you a very good idea about the magnitude, the scale of the impacts. It fits in other paradigms that people are used to. And what is quite good is that you can compare the potential impacts in compare them across different scenarios and alternatives. And it also may help you to have a good discussion with your stakeholders about the health impact assessment. So, but what do you need to know? Need to do or need to know if you start to do a quantitative health impact assessment. Key steps, colleagues already 20 years ago formulated these 3 points that are still valid. First of all, think about what kind of pathways you are looking at. And then if you did that, you need to have a model. Either you develop yourself or you use a model that was developed by others. And you need also to think about what kind of outcomes do I consider in my assessment. It could be diseases, it could be mortality, but also some colleagues use dollars or euros to calculate it. To give you an idea what I mean with causal pathways and causal web, this slide shows you a causal web for a health impact assessment for airport runway extension. So you see, the idea is the runway will be extended, and there are multiple determinants of health that you can consider, and you need to think about, okay, how is the exposure in all those blocks over here? What is the strength of the association between these, and which modeling approach can I use in here? Most of the models that are used in quantitative health impact assessment use, if you think about the causal web and how to model this from policy to outcome, then most models focus on the part risk factors and health outcomes. Some of the models also include costs, but these are really rare, although there is more and more work done in the last few years. So all the models are using risk factor and health outcome. Models can be distinguished between risk assessment models and population-based models. The risk assessment models, Helmut mentioned environmental health impact assessment in the beginning. These models are used in that kind of area, so environmental health, but also consumer protection, and population-based models are mainly used in public health. I will give you 2 examples of this so that you can understand what the difference is between them. So risk assessment models, they use the risk assessment framework, hazard identification, dose response assessment, exposure assessment, and if you put all them together, then you can characterize the risk or the health impact in our case. And for the main part is exposure modeling. If you do the health impact assessment, the dose response part, toxicologists or epidemiologists will have measures for that. So if you are going to do a health impact assessment using risk assessment models, then you focus mainly on the exposure modeling. And you see over here, it's a quite easy formula that is being used. You have the concentration of your contaminant or your risk stressor, for example, in food, and you have other factors like intake rate, how much food is eaten, how often, how long, and that is justified by, or is based on a body weight measure. To give you an example for this kind of model, we did a you see here a table with results of such an exercise. In Germany, the drinking water was planned to get privatized, and people were anxious, or we were interested to see, okay, what would that mean if the legal limit value gets exhausted by this drinking water privatization policy that was planned. And we calculated with the risk assessment methodology for several carcinogens the potential additional cancer cases for this policy. And if you look over here, North Rhine-Westphalia, so if and we had different scenarios, so if the legal limit value would be exhausted by 100%, so legal value, then we would expect additional cancer cases of approximately 11,000 cases over the life course. So this is typical example what you could do with risk assessment methodology. This is state of the art people in consumer protection, environmental health are doing. And you see over here numbers that you can compare quite easily. But over here you see carcinogens, and it is only that you can compare carcinogens quite good with this methodology. If you would have other risk stressors, that would be not a good way of doing it. And then other models come in, for example, use population-based models. So before we had the exposure and we had the exposure relationships. So that's the risk assessment strategy approach used here. But if we do population-based modeling, we take additional information into account. For example, how much people are living, and and in what area, in what exposure levels do they experience. And we also look at outcome frequency already there, and combined together, we can calculate attributable cases. So this is another way of modeling, and you get also other results out of it. We did this kind of population-based modeling in different approaches, different examples shown over here. So it is a wide range of examples you see over here. And we also use this kind of modeling to forecast how much cases we would expect based on the demographic change in North Rhine-Westphalia for specific health outcomes for different regional areas in North Rhine-Westphalia. So it's also an example how you can use population-based models. Maybe the most prominent and also known to you is the burden of disease approach as a population-based modeling approach. And the burden of disease approach was developed early 2000, so around the 2000. And nowadays it's quite common. Almost everyone knows what in the area of public health knows what burden of disease is, but it is a standardized, that's a very important framework for integrating all information on mortality, causes of death, risk factors, etc., and to provide an overview of the levels of to provide overview of population health and the causes of loss of health. So it is on population level, it is complete and comparative. That's also quite important, and it expresses has different health outcomes you can do. You can look at. On the right side, you see the cover of a report I was working together with other colleagues in Europe, where we estimated the burden of disease in an environmental burden of disease study for in 6 European countries and for 9 stressors. So we had a standardized framework, so we could really good compare the level of population health in different terms. So burden of disease, I took into, I looked at India, where what did the Institute of Health and Metrics and Evaluation, IHME, they are doing great work on producing global burden of disease studies. And you see on the left side, you see the 10 most, the 10 diseases that are the leading diseases for death and disability in India. You may be familiar with this presentation, with this, and on the right side you see, so it's only not about disease, but also about, okay, which risk factors drive this death and disability combined. And what the colleagues did 2009 and compared it to 2019 analysis results. And you see here that the weighing is moving, what is really good. But what does this has to do with health impact assessment? So these are modeling exercises, but they do only look at, okay, current state on a time point t0, so they calculate attributable burden. But if we look into the future, then we not only will look at the attributable cases, but also avoidable burden at t0. So these different, I don't know if you see my mouse cursor going up and down. So in health impact assessment, we look into the future, and we consider different scenarios or different options, and you can also do it with burden of disease. But colleagues internationally are doing it not that often, but you can do it, and we did it also in the past.
Okay.
Yeah.
Okay,
Short.
that was a, yeah, let's have a short break so that you can take a breath. And of course, that was a little very technical for the beginning. But I think in our audience, we have some engineers, we have statisticians, we have epidemiologists, and we have public health practitioners. So most of those things are known to you. The crucial question, of course, always is, well, is there an example where you did it, where you got it right with your predictions? Is there an example that you can tell us?
So that's the monitoring evaluation part. So that is actually something we never looked at it after we did some of these exercises. And so that is currently, now we didn't have a look at it, but and also it is all often the case that you try to in health impact assessment, Liz will go into that, can go into that also in more detail, that you give, so based on your analysis, that you come to recommendations how to minimize negative aspects and also to optimize positive aspects. So sometimes the number as such, what you predict, or these are estimates. So it's also quite important. These are estimates, so that you show the direction.
Now that is clear, because you cannot predict exactly what's happening, but you can offer different scenarios. What will happen if you do something? And of course, I guess most of our listeners now would ask the question, well, you gave this nice example of the drinking water privatization. So what happened?
It didn't. It wasn't privatized. So that's.
Okay. Were your arguments counted?
They didn't. No. There were other political decisions that were taken to not to go this way, to drinking water privatization. But at the time, it was quite at that time.
Yeah.
So it's all
Okay.
already 20 years ago. Yeah.
Okay, good. So we have set the scene, and now your part two will look a little bit about what we can do for the other areas. Please go on.
Okay. So in my second part, so you need to always, so if you have your idea, okay, I want to model, then the question is, do I make my own model or do I select a model that is developed by others? And in doing so, we were also in this phase. What are what kind of models do we have? And then we noticed that so we started to compare different models, and then we noticed these model developers and users are developing their own models, but there is hardly any exchange between them. And also to find out for us which model would be the best for use in our institute, we started a series of workshops together with model developers and users, and did also a survey in addition to look at all these different models and aspects. And there are quite a lot of models out there in the world, and we had specific. We couldn't look at all the models, but and also the models that were at that time. What the models were dealing with were exposures, as you can see over here. So most of the public health risk factors that we are all working on, but also different models have different diseases that they already implemented in their models. So ischemic heart disease. So here you see also quite a lot of known and known diseases where we all work on, and the outcome measures you see down there. So what we concluded from this exercises is that we that there are quite a lot of models already good in use and can be used for quantitative health impact assessment, that all these models are still developed, and that's ongoing business. But what also, together with the model developers, they said, we don't need another new tool, but we need to develop it further, the tools that we have, especially also to take into account the inequalities, but also the uncertainties in models. That came out at that time. And for us, we saw one model which I want to introduce to you and let you show you a bit what kind of data you need to put in and what comes out, to give you a flavor what how such a model is looking like, is the Dynamo HIA model. It's a generic software tool. It's a generic instrument. Already 9 chronic diseases are included. So the model is already populated with data and also populated with risk factors. So you have already these data. How what's the prevalence in the in my population? Those response functions are already included, and you can model alternative exposure scenarios, which allows comparison. And we did use this model for North Rhine-Westphalia for body mass index and physical activity. And physical activity is not a risk factor that's already included, so that was one we inserted, worked on to get it into the model there. So this slide shows you which data is necessary and goes into this model. So on one hand, we have population data. You need to have the number of people who are living in your area, and we had 2005, 2009 data for it, risk factors and diseases. And for prevalence, we put in North Rhine-Westphalia data, so where it is bold, these were North Rhine-Westphalia data. And we did it for BMI. I show you a few scenarios. So when you do the modeling, you start also with scenarios. The model already itself has the the reference scenario. It is always compared to the reference scenario. The colleagues who developed the model say it is not a prognosis. It is because the model should have different, but you compare always to the reference scenario, and we developed a scenario where everything goes worse, and we have two scenarios where preventive measures are in place, which reduce the BMI in all groups in different levels. So these colors are important. So if you start, and we did this exercise for 2010 with a projection to the focus year 2034. And the next slides show you some of the outputs. So over here, the prevalence of the risk factor and BMI over time. So how many people are obese, overweight, and normal weight. And the blue line is the current, so the baseline and a reference scenario. We see, and on the bottom you see the timeline 2010 till 2035. Is displayed over there, and you see the red one. The red scenario is the bad scenario, the worst scenario. So these are so you put in your baseline and the model calculates it over time. You see that, and not only the risk factor influences the prevalence of the for example, type 2 diabetes mellitus over time. And here you see the development over time. And on the right side, you see the blue line is the reference scenario. So you can calculate the excess number of diabetes, people with diabetes compared to the reference scenario. And there are different ways of displaying it. Also, you can zoom in into 1 year and look at in the year 2034 and look at specific age groups, how they would perform, and not only the prevalence, but also earlier, like compared to the reference scenario, that you can display the excess numbers compared to this reference scenario. And you can do it. I displayed it for diabetes. You can see it also. You can also display and calculate it for other health outcomes, like you see over here. And for mortality, it's also one of the endpoints you can do. You will get all these slides afterwards so that you can go into detail to look at it. We had workshops conducted with colleagues who develop models, but also if you are working with a specific model, it's good to have contact to other developers and users to ensure your quality of the work you're doing. So we organized 15 workshops with developers and users. You can see here what kind of other risk factors and policies, in which context others are doing this modeling. So salt reduction, traffic related air pollution, and we did physical activity. And it's quite useful to keep in contact, but also, so we, if you are interested to read about this workshop, we provide a workshop documentation. And on the right side, you see physical activity report. We introduce a new factor in this generic instrument, generic tool, Dynamo HIA, on physical activity. This risk factor was not already included. And you need to collect data, you need to process the data, you need also dose response functions, and we put it in this report, and also you can find it on the on our website, but also at the Dynamo HIA website, because we did a lot of this work and we share this work with others so that they also can use it and start to work on it quite quickly. So I take a big breath, Helmut.
Yes. Yes, that's okay. That was some examples where we now could see what kind of results you are able to produce with this. And I guess instead of BMI, we then put climate change in it. So this seems to be generic application that can be used to analyze the consequences of what we are doing. And but when one listening to you and having all this in mind, for example, when you do this health impact assessment for a project you're planning, this takes time. Aren't you slowing down the realization of new projects by requiring this kind of analysis?
So it is time consuming doing these kind of models, but if you are so it is time consuming if you are not familiar with the model, to get a model, to know the model, to have so that's the time consuming. If you are already familiar with the model and do it quite regularly, then it is not delaying the work in the HIA.
Okay, the next question, of course, is transferability. Can these results be transferred and used in another setting? For example, there might be the same problem. Can they say, oh, in Northern Westphalia did it and they got the following results, so we can just adopt them, or do we have to go through the whole cycle again?
It depends. It depends how similar your population is, how similar the baseline health status is. Such things are also relevant for doing this kind of modeling exercises. But the idea is this model, you can populate it with your own data. So for your own data, and I go back a few slides earlier over here. So you populated here, I show over here where we put in Northern Westphalia data. So the other data we left there. So if colleagues in India or in Wales, Liz, where Liz is based, she can do put in her data for her country, for her region.
Good. Okay, and now we come to the last part, and you can compress this if you like.
Yep. So so in the area of climate change, there are a couple of models that are freely available, were developed by WHO in Europe. They were, and there are linked already. There are YouTube webinar links too, and I will go quickly through. AirQ is, as the name already says, is on air pollution, and it is designed for public health and other specialists with a minimum knowledge of modeling and statistical methods. And they all have in common that they allow scenario analysis. So what would happen if if the situation is a different one? Another very interesting tool is HEAT, Health Economic Assessment Tool for walking and cycling. And what are the effects on emissions of carbon? So that's there comes climate change in, and what is different from other models is that economic part is also part of this model, but it is unfortunately only looks at mortality and not on other health outcomes currently. But I think they are planning to do other health outcomes too. And a quite new released model is the carbon age, and it also includes the cost dimension. And I would, so if you are going on that path, I would recommend to have a look at this tool to if it works in your environment. And in Europe, green spaces are discussed that, and for that, colleagues are developing a software tool based on GIS, Geographic Information System, and they are currently testing this tool. So, in conclusion, there are a lot of models you can use for health impact assessment. You need to invest time and resources. These models and tools are also available for climate change. Depending on your question, simple or more complex models you will or could use, but still the translation of your policy question. So, climate change, you put it in a model and everything comes out. You need to think about how you model your policy, and there are still areas where you cannot model because the data is not available. And sorry. And in previous times, the reach and uptakes of these modeling results for decision making was still underdeveloped. But in the COVID-19 time, a lot of models are produced, and decision makers are taking these models and results of these models also quite serious, at least here in Europe. I will be happy to hear how it's in India. So, last slide. Not everything can be quantified is important, and not everything what was in 2001 quantified was done robustly. So that's also, you need to be robust and you need to be transparent in your modeling, and not everything that's important can be quantified. So because of lack of data. Thank you very much. I hope I could give you a bit of a flavor what things are important if you are interested to do quantitative modeling in health impact assessment.